Hello students, welcome to all of you in this video lectures. In this video lecture I am going to continue the chapter 4. The name of the chapter is Determinant. Here I am going to explain the concept of minors, cofactors, adjoint of a square matrix and how to find the inverse of a square matrix. So students, it is very important. So first of all I am going to explain what is minor and cofactor. So minor of an element Aij of a square matrix of a determinant is the determinant obtained by deleting its ith row and jth column in which element Aij lies. For example, in this determinant, the position of the first element is A11. So students, in order to find the minors of this element, we have to delete its first corresponding row, means first row and first column. Then the rest elements will form a 2 cross 2 determinant and it is nothing but the minor of this element. And these are 0, 4, 5, minus 7. And using after expanding this we will get minus 20. So students, like this we can find out the minors of each and every element. Suppose we are going to find the minor of 5. So you have to delete its corresponding row and corresponding column. The remaining elements forms a 2 cross 2 determinant 6, 0, 1, 5. And after expanding this, we will get the minor of this element 5. So student, this is how to find the minors. I hope all of you understood. Now I'll tell you what is cofactor. Cofactor is nothing but, if we are going to find the cofactor of an element Aij, first we have to use this formula minus 1 to the power I plus j into its minor. So students, if we multiply this minus 1 to the power I plus j into its minor, we will get its corresponding cofactor of that element. Suppose in this determinant the minor of 2 we have got minus 20. So what is the cofactor of 2? So it lies in first column and first row. So you have to do minus 1 to the power 1 plus 1 because its number of rows 1, number of columns 1. So minus 1 to the power 1 plus 1 into its minor. Minus 1 to the power 1 plus 1 is minus 1 square, it is plus, and minus 20 plus minus minus, so answer is minus 20. So students, like this we can find out the minor and cofactor of each and every element of this determinant. So I hope students, all of you understood. Let us take one example here. One question is there: find minors and cofactors of the element A11, A21 in the determinant. So in this determinant, in order to find the minor of A11, we have to delete its corresponding row and corresponding column, and the rest elements are form a 2 cross 2 determinant, and these are A22, A23, A32, A33. And after expanding this determinant, we will get the minor of A11. Now, how to find the cofactor of A11? Cofactor of A11 will be defined by capital A11. Okay, and it's minus 1 to the power I plus j. Here I is 1 and j is 1. So minus 1 to the power 1 plus 1 into its minor. So it is square, so it is plus 1 into its minor. So answer will be this one. Similarly, for A21, we have to know where the element lies. A21 lies in this place. So in order to find the minor of this element, we have to delete its corresponding row and corresponding column. The rest elements are A12, A13, A32, A33. So A12, A13, A32, A33. After expanding this determinant, we will get this, and the cofactor of this element will be A21 minus 1 to the power I plus j. Here I is 2 and j is 1. So minus 1 to the power 2 plus 1 M21. So minus 1 to the power, it's minus 1 to the power cube. So it is minus 1. So minus 1 into its minor. So its minor is this we have got. So after multiplying this by minus 1, we will get the cofactor of A21. So students, I hope all of you understood how to find the minor and cofactor. There are some important points to be remembered. if elements of a row are multiplied, if elements of a row or column, particular elements of a row or column, if you multiply it with its cofactor of any other row or column, then their sum will be 0. Okay students, for a particular row or column, if you multiply with its cofactor, multiply with cofactors of any other row or other column, then their sum will be 0. For example, this is the sum of this will be 0 always, a11, a21. This is the elements of the first row, a11, a12, a3, a13, and we are going to multiply this element with the cofactor of other element, the cofactor of second row. So a11 capital A21, a12 capital A22, a13 capital A23. So when you multiply this, when you simplify this, you see that this determinant will form where the elements of two row are identical. First row and second row elements are identical, and we know that by the properties of determinant, the value of this determinant will be 0. So I hope students you understood this point, this very important point. And next I am going to discuss how to find the adjoint and inverse of a matrix. So students, the adjoint of a square matrix A is defined as the transpose of the matrix. Transpose of the matrix where Aij, where Aij is the cofactor of the element Aij. So students, adjoint is nothing but the cofactor transpose of the cofactor of matrix A. Okay students, adjoint of a matrix is defined by the transpose of a cofactor of a matrix A. For example, this is a matrix A. Okay students, and its cofactor, we know that cofactor is defined by capital A11. So the cofactor of A11 is capital A11, cofactor of A12 is capital A12, cofactor of A13 is capital A13, cofactor of A21 is capital A21. Like this, each and every element cofactor are there, and using this cofactor will form a matrix. And if you take the transpose of this matrix, transpose of cofactor of matrix A is known as adjoint of A. And if you take the transpose of this matrix, the first row becomes the first column, A11, A12, A13, A21, A22, A23, A31, A32, A33. So this is the adjoint of the matrix A. So I hope students you understood how to find the adjoint of matrix. There are some important theorems which is very important. First theorem is a square matrix A is singular if A equal to 0, right? If A equal to 0, if the determinant of A equal to 0, then the square matrix is said to be singular, right? And a square matrix A is said to be non-singular if the determinant of A is not equal to 0, right? If A and B are non-singular matrices of same order, then AB and BA are also non-singular matrices of same order. The determinant of the product of matrices is equal to the product of their respective determinants. For example, determinant of AB is equal to determinant of A into determinant of B, right? Where A and B are the square matrices of same order. A square matrix A is invertible if and only if A is non-singular matrices. For example, determinant of A is not equal to 0, right? The inverse of a square matrix A is given by the formula A inverse equal to 1 by determinant of A into adjoint of A. Now, this is the formula of finding A inverse. I am repeating again, A inverse equal to 1 by determinant of A into adjoint of A, right? And how to find the adjoint of A? Already I have discussed. Adjoint of A means transpose of cofactor of matrix A. So transpose of, this is the cofactor of matrix A, and its transpose is given. So this is the adjoint of A. So student, this is one the proving of the theorem 5. A square matrix is invertible if and only if A is non-singular matrix. So students, let A be an invertible matrix of order n and I be an identity matrix of order n. Then there exists a square matrix B of order n such that AB equal to BA equal to I. Right? The students, if A is invertible, then A must have inverse. So B, let us say that B is the inverse of A. In such case, you can write like this: AB equal to BA equal to A, where B is the inverse of A. Right? Now, when AB equal to I, so determinant of AB equal to determinant of I. Yes. Now, determinant of AB can be written as determinant of A into determinant of B equal to 1. The determinant of I is 1. Now, determinant of A into determinant of B equal to 1. So, both A and B should not be equal to 0. Right? So, determinant of A not equal to 0, which means that A is non-singular. Conversely, if you see that, let us take that A is non-singular and determinant of A is not equal to 0, then we can write A into adjoint of A equal to adjoint of A into A equal to determinant of A into I. Right? This is one theorem we have already proved it before. Now, if we divide both sides by determinant of A, we'll get A into 1 by determinant of A into adjoint of A plus equal to 1 by determinant of A adjoint of A equal to I. And if you take this equal to B, so you can write AB equal to BA equal to I, where B equal to 1 by determinant of A adjoint of A. Hence, this proves that A is invertible and B is the inverse of A, and the value of B is, or A inverse is 1 by determinant of A into adjoint of A. So I hope students you understood the theorem. Let us consider some questions here. We have to find the adjoint of each of the adjoint of the given matrix. The matrix is given. So students, we know that the adjoint means the transpose of cofactor matrix of A. So first of all, we have to find the cofactor of each and every element of the given matrix. So A11 is the cofactor of first element 1. So if you delete the corresponding row and corresponding column, the elements are 3, 5, 1, 0, 3, 5, 1, 0, and after expanding 3 minus 5, 3 minus 0 is 3. So this is the 3 is the cofactor of 1. Next, cofactor of minus 1. It is here the sign is minus 1 because it is minus 1 to the power 1 plus 2. So here sign is plus, minus, here plus, minus, plus, minus, plus, minus, plus. So here sign is minus, so minus into, leave its corresponding column and corresponding row, 2, 5, minus 2, 1. 2, 5, minus 2, 1. So after expanding, you will get minus 12. Then cofactor of 2, here sign is plus, minus 1 to the power 1 plus 3. And leave its corresponding row and corresponding column, 2, 3, minus 2, 0, 2, 3, minus 2, 0. After expanding, we will get 6. Similarly, we can find out the cofactor of each and every element of this matrix, and after finding it, we'll get a cofactor matrix over here. This is the cofactor matrix, and now we take the transpose of cofactor matrix. So this is the transpose of cofactor matrix, which is written as adjoint of A. Students, already I have given you the formula how to find the adjoint of A. This matrix is taken the transpose of cofactor of A because A11, A12, A13. It was the elements cofactors of the first row. Now it is become first column. Similarly, this is second column, third column. After putting the value, we will get the adjoint of the given matrix A. So I hope students all of you understood. Next question, it is very important to find the inverse of the matrix if it exists. The students, in order to show whether it exists or not, we have to find the determinant of this square matrix, and if it is not equal to 0, then we say that inverse is exist, and if determinant of this matrix is equal to 0, then inverse does not exist. So first we have to find the determinant of this matrix A. Let A be the given matrix and determinant of A is equal to -1. Hence A inverse is exist. Now we have to find the cofactor of each and every element. The cofactor of 1, leave its corresponding column, corresponding row and corresponding column. 2 minus 3 minus 2 4, so 8 minus 6 will be 2. Now cofactor of -1, leave its corresponding column, corresponding row. 0 minus plus, minus 1 is plus 9, so 0 plus 9, here sign is minus, so it is -9. Similarly A1 3, leave its corresponding row, corresponding column. 0 minus 6, 0 minus 6, and here sign is plus, so -6. A21, here sign is minus, so minus. Corresponding column, corresponding rows. 8 minus this one, so corresponding row and corresponding column. So 4 minus 6, sorry 4. A21 this one, so you have to leave corresponding row and corresponding column. So it is -4 plus 4, so it is 0. So like this, students, you can find the cofactor of each and every element. After finding it, we will get the cofactor matrix of A. Cofactor matrix of A is given by this, and if you take the transpose, of this matrix, this is the adjoint of this cofactor matrix of A. And how to find the A inverse? Using the formula 1 by determinant of A into adjoint of A. So determinant of A is adjoint of A is this one, and 1 by determinant of A we have got -1. So -1 into adjoint of A. So after multiplying this whole elements by -1, we can get the final answer. A inverse is the inverse of the given matrix. So students, next question is very important, which is for a matrix A, show that A cube minus 6x square plus 5A plus 11I equal to 0, and hence find A inverse. So first of all, we have to find this term A cube. A is given, so A is given. First we find A square, A into A. So students, you know how to find it. First row into first column, 1 into 1 plus 1 into 1 plus 1 into 2. Like this, we can find the S square, and its value is this: 4, 2, 1, minus 3, 8, minus 14, 7, minus 3, 14. And now A cube you can find out by S square into A. So S square we have got here, and A is given, and after multiplying these two matrices, we got the new matrix is 8, 7, 1, minus 23, 27, minus 69, 32, minus 13, 58. Now using the left hand side, which is given A cube minus 6s square plus 5a plus 11i, substituting these matrices, and after simplification, 6 is the multiple of this matrix, so we have to multiply each and every element by 6. 5 is the multiple of this matrix, so we have to multiply each and every element by 5, and we have to multiply each and every element by 11 in this matrix. And after simplification, we got all the elements are 0, hence the right hand side is 0. We have proved it. Now next we have to find the A inverse. So students, here A cube is there, so first of all we multiply both sides by A inverse. When you multiply both sides by A inverse, here it will be A square, and here it will be 6A, because each and every element you have to multiply by A inverse. Then one A inverse and A will get cancelled, so here it will be A square, 6A, 5 A inverse cancelled, and 11 A inverse. And if you change the side of this, it will be minus 11 A inverse equal to S square minus 6A plus 5I, and A inverse will be equal to 1 by minus 1 by 11 S square minus 6A plus 5A. So students, already we have got the value of S square. A is given, I we know. Substituting these matrices, and after simplification, we got the value of this matrix is 3 minus 4 5 minus 5 minus 9 1 4 minus 5 3 1, and hence the A inverse will be equal to minus 1 by 11 minus 1 by 11 3 minus 4 minus 5 minus 9 1 4 minus 5 3 1, and after multiplying each and every element by minus 1, the final answer of A inverse will be 1 by 11 3 4 5 9 minus 1 minus 4 5 minus 3 minus 1. So students, this is the answer of A inverse. I am ending today's video. Here in this video I have explained the concept of minors, cofactor and inverse of a square matrix using determinant method. I hope all of you understood. If you have any doubt, you can contact me. Thank you very much.